right. Thank you, Phil, for the introduction, and thanks everyone for being here, and for those of you watching online. I'll kick off with a brief introduction. My name is Arman Gungor. I'm a forensic investigator and also the founder of a Los Angeles-based digital forensic software company called Metaspike. At Metaspike, our focus is email forensic software, so handling the preservation of email evidence and analysis of email evidence, and email forensics training. In this presentation, I'm going to be talking about email forensics mostly, but before we do, can we have a show of hands for anybody who focuses on email forensics? So most of what you do is email forensics. Anyone? Oh, there are a couple. Yeah, all right. So we do have a couple of people. Great, excellent. So a very brief introduction to email forensics. The way I look at it, it has essentially three components, right? It has the items. So we're talking about email messages, the attachments of the email messages, the modern attachments of the email messages. So if there's anything hyperlinked, any non-email items that you might find in a mailbox, for example, sticky notes or calendar invites and things of that nature. And then there's the systems where you might have emails on a workstation, on a mobile device, on a server, so any type of endpoint that could house email evidence. And then there is the service providers and the cloud and the email gateways and the email security and compliance systems, the logs, backups, and all that stuff that's mostly remote. So because of this, this ties into a lot of the different email forensics or digital forensics practices, like, from dead box forensics to mobile forensics to network forensics, cloud forensics. So you might be doing a lot of different things if you're involved in email forensic investigations. However, in general, email forensics or digital forensics workflows, what I've seen is that investigating email data usually revolves around ingesting the emails, extracting their attachments, extracting a select few metadata fields like the subject and the attachment names and the senders, recipients, and things like that, and then making a searchable index. And then you get the emails to essentially review and examine. But in my view, that's mostly scratching the surface. There's a lot more detail in email evidence, and it's, in a lot of cases, worth looking into. So that's one of the points that I'll try to illustrate in this presentation. So where do we use email forensics? Because of how common email evidence is and how important it is, just about anywhere. A lot of people discuss important things in email, so it is the subject of a lot of lawsuits or investigations. If you're a bad actor, compromising email gets you quite far. So because of that, anytime there's email fraud, business email compromise, phishing emails, malware delivery, or even ordinary business disputes like contract disputes, misappropriation of trade secrets, we lean on email forensics. And the agenda today, what I'm going to focus on is essentially a narrow slice of email forensics. We'll look at items, and within the items specifically what marks email clients leave when they are, for example, creating emails, copying and moving email data, editing emails, or forwarding emails. So typical user actions. I think one of the cool things here is that we're going to look at some real email data, and I will provide the data as well, so you can download it and take a look at it. I wouldn't suggest doing it right now, but at a later time, at your leisure, you can just download and play with those emails yourself. So I might have gone a little farther. Well, I think I'm perhaps not seeing a slide here, but we're starting off with essentially a new email message. You don't see the face of the email here, which should be in one of the slides here, but it's essentially a basic email with an inline image as part of the sender's signature, and then an external attachment that's a zip file. So the email is created, and we document essentially the date and time when the email message is created. And then we're going to look at the actions that we take on it and how the artifacts we see on the email kind of tie in with these. Well, I'm missing a couple slides there for some reason, but let me go through it manually. So one of the headers there that we see right off the bat, let's start with the easy stuff, is the Xmailer header, and that points to Microsoft Outlook 14. So that's pretty simple stuff, and it's telling us essentially what email client had been used to create it. And in this case, the email was created using Microsoft Outlook 14. So that's an obvious tie in there. The next item there is the message ID header. In this case, if we look at it in detail, there is the unique identifier of the email. And let's take a brief pause here and talk about who creates the message ID. Have you given some thought? Is this created by the email client or the email server or somebody else? It is typically created by the email client. So it's part of the composition aspect of the email. The email client creates the message ID, which is supposed to be a unique identifier for a specific instance of the email. And then as it reaches the email server, in this case, typically the first receiving email server would be the mail submission agent. It has authority to actually update this message ID if needed. So if it doesn't like the syntax of it, there's something illegal about it, or if it's missing entirely, it could actually replace it. In this case, it is not, so it'll keep that. But because the email client creates the message ID, we can glean a couple of things from that. Number one, we can figure out what email client that is, perhaps. In this case, this is consistent with Outlook. And we can also sometimes find timing information, because when you look at the message identifier, because it has to be unique, a lot of email clients lean on timing information to create that uniqueness. They usually use some high precision timestamps. So in this case, we're looking at a file time value within the message ID. And for those of you who are not familiar, file time is essentially an 8-byte timestamp that tells you the number of 100 nanosecond intervals from the year 1601. So it is a high precision timestamp, and Microsoft uses these all over the place. You'll find them in NTFS, you'll find them in the compound file binary format, like old style Word documents. You'll find them in MAPI, you'll find them in these Outlook artifacts. And if you were to convert that to human readable form, well, this was the slide that I was missing, so things got a little out of order here. So let me go through these a couple of ways. All right, so I don't know how the slides got shuffled here, but let's back up for a second. So this is the email that we're talking about. And this is the face of the email. And you can actually download this and some other emails that we're going to talk about here with this QR code, or if you follow that URL at a later time. So I'm glad that it turned up, although out of order. And here's a description of how this email is created. This is actually good that we're getting to see this. So when we created this email, we used Outlook 2010, and the workstation name is as listed, and the IP address is there, and we recorded the dates and times of the actions that we've taken. So when the new email button was created, it was 11:21 p.m. UTC, and the send button was clicked on 11:23 UTC, so a couple of minutes later. So it's important to note that they're not exactly at the same time, and we might be able to glean some timing information from there. So let's go back here. So this was the Xmailer header that I was talking about, and that is pointing to Outlook 14 here. And Outlook 14 was used, so there's that tie in there that I was talking about. So going back to the message ID, so we're looking at this file time value. If you convert that to a human readable form, it's showing us 11:23 p.m. in UTC. And if we recall, that was the exact time of when the send button was clicked. So that is not the time that we actually created the message, but the time that we sent it in UTC. And if we compare that exactly to the origination date, which is also known as the date header, so we can see that it is the same time with a minor difference, about 3 seconds different there. So that suggests that Outlook created the origination date header first, and then a few seconds later populated the message ID and used that timestamp there. Now moving on to another email client artifact, there is the thread index. And I'm not going to get into too much detail there about the thread index, because this was the subject of my last presentation here. You can watch that there. But suffice it to say that this also contains timing information. If we convert this to hexadecimal from base 64, the beginning part of it actually is another file time value. And if we do the human readable conversion of the timestamp, we see 11:21 p.m. UTC. And if we recall, that is the time that the new email button was clicked on. So it was not when we sent the email, but when we created the email. So this gives us some interesting insight, actually a few things. Number one, the thread index might be able to tell us when the first message in the conversation was created, not necessarily sent. The second thing is because of the difference between the time from the thread index and the origination date of the email, we might be able to surmise composition time or an approximate composition time. So how long it took from the message being created to it being sent. And this also applies to those delayed send scenarios. So let's say that somebody used an email client and they used the feature to not send the email immediately, but send it at a scheduled time, then you would see a difference there. The one artifact that'll tie in back to the original creation time of the email will be thread index there. And then it has some other benefits too. You can look at the child messages. So if there are multiple messages in the conversation thread, you would see them and be able to construct a skeleton of the entire conversation. And each email thread has its own unique identifier as a GUID, and you'll be able to use that in contextual analysis, as I'll discuss in a little bit. Now, going back to the headers here, we have a content type header, and this contains a MIME boundary. And again, if you're not familiar with MIME boundaries, so if you look at an email message in internet message format, it's going to be a flat file, a text-based file, and it has multiple parts typically. And each MIME part is going to be things like the text body of the message or an HTML body of the message, the inline attachment, or an external attachment. But to be able to represent these accurately, they have to be separated by markers, like separators. So that's what this MIME boundary is. And if we were to ask the same question again, who creates this artifact? We come back to the email client, because it has to be there as the email is composed and it's going out the door. Before it reaches the server, even the structure has to be there before it's transmitted. So as such, we might be able to, again, figure out what email client may have been used to create this and perhaps get some timing information. In this case, this is, again, consistent with Microsoft Outlook. And there is a file time value here. If you convert this to human readable form, we see another timestamp. And this is familiar because this is also the time that we click the send button. But if you pay attention here, it is not in UTC, it is actually in local time. So it doesn't have a time offset, it just gives us the local time of the user. And that is good and bad. It's good in the sense that if you have other timestamps to rely on, let's say you have the origination date of the email in UTC, perhaps with the time zone, and if you have this, then you might be able to get a difference of those two values and figure out how many hours off the user is from UTC, which would be their time zone. So you could figure out what time zone the sending computer was in. But the downside is, if this is all you have and nothing else, then you can't really get a super accurate timestamp there because you don't know the time zone, you just know the local time. Moving on, here is a received header, the first received header here. And the reason I include this is the information that it contains. So this is one of the questions that I get quite a bit. And just last week, somebody asked me, they emailed me and they said, hey, Arman, nowadays we can't get the IP address of the sender in emails, right? And I said, not right. You might be able to, depending on the situation. In fact, this email is from just a couple of weeks ago, and it not only contains the IP address of the sender, but also the computer name. Here's, if you recall the previous slide, the computer name was this, so it's a little bit different, normalized. IP address was that, and it was all in the received header. So it comes down to the email client. In this case, the email client was helpful to capture that information and include it on there. Moving on, we are now getting into the HTML body of the message, and we see some references to Microsoft Word 14 here. This makes sense because we had used Outlook 2010, which is Outlook 14, so that ties in nicely. And then we see some references here to the inline image. So there's the content ID here. The part that starts with CID references that content ID, and it is a unique identifier for that MIME part, and the reason for its being is this. In the HTML body, there's going to be some inline elements sometimes, like in image. And when the email client is rendering the message, it has to know where those pieces are to put it together. So the image is in a different place. It's a different MIME entity. So it has a specific address so that the email client knows where to find it. So that's what that identifier is there. But if we highlight these, there are essentially three components here that I'm looking at. One of them is, again, a file time. And again, it points to the time that we clicked on the send button. And once again, it doesn't have a time zone. So this is, again, a local time artifact. The second thing is a string here. And you may not know this, but this was the file name of the inline image that was in the person's signature block. So before that was inserted on there, the name of the file was this tdamian.png, and that is captured here, and it's included as alt text in that HTML. And this identifier here is a generic name that Outlook uses for numbering and naming inline images typically. So we have created the image, we've created the email, and we documented what we did and when, and some basic initial artifacts. Now we're going to take some actions on this email and see what kind of tool marks we observe as the email client touches them. The first thing I'm going to do is to copy this email, but I want to think first and set expectations. So what do we expect will happen when we copy an email? What do we expect should happen when we copy a file, for example, in the file system? Do we expect the file's contents to change? Do we expect file system metadata to change? Anything else to change? For a file, I would expect some file system metadata to change as you copy it, but not necessarily the contents of the file unless something went really wrong. When it comes to copying an email, that depends. And my initial expectation was similar. I would have expected that the contents of the email would remain the same, but the server metadata would change. For example, the IMAP unique identifiers of the email would change, the IMAP internal date would change. So some reference to that email would change, but not necessarily the contents. But we'll see that that's not always the case. So in this case, we're copying the message. We switch versions now, and we're using Outlook for Microsoft 365. So the most recent version of Outlook that was available when I did this exercise. And the copy operation is performed on the same day, a few minutes later at 4:32 p.m. in Pacific time. Now, one thing we notice is that because of this copy operation, a new header has been added to the email, an Outlook-related header. And interestingly, 3 headers have been removed from the email. That is kind of unexpected. And out of the 3 of them, the one that is more concerning to me is the DKIM signature header. I'll mention this very briefly to give you a quick summary of it. DKIM stands for Domain Key Identified Mail, and it is essentially relying on public key cryptography, and it is digitally signing the contents of the email and its attachments and a subset of its headers, and the signature is signing is performed by the entity who assumes responsibility for the email, like the email service provider, for example, like Google or Microsoft. And once it's signed, then the receiver can retrieve the signer's public key and then verify that signature. And if everything checks out, then you can have good confidence that that email hasn't changed since it's been signed. So needless to say, it is a fantastic artifact for email authentication. And as such, when you see it missing in an email that should have had it, but it doesn't have it anymore, that might throw out some red flags. You might think, that's interesting. This email should have had a DKIM signature. It's from Google. It's from a couple of weeks ago. What happened to this? And you might think maybe some bad actor tampered with this, and to cover their tracks, they removed that header entirely because they can't possibly recalculate the DKIM signature without Google's private key. So it might give you a false impression, but in this case, it's the email client taking off that header. Another fascinating artifact here, I think, is that the received headers are shuffled because of that copy operation. This is interesting because if you look at the SMTP specification, RFC 5321, there's a paragraph there that concerns the trace headers, received headers, and the specification says that an email gateway is supposed to prepend received headers as the email is transmitted, and it's not supposed to interfere with existing received headers that are already there. So this is not gatewaying, of course. So we're not dealing with a gateway here. This is local email operation. But it's kind of contrary to how email systems should behave to see that the headers are being shuffled. So again, when you look at an email like this and you see that the email received headers are out of sequence, you might think, something sketchy happened there. Maybe somebody pieced together these received headers, when in reality, in this case, you just copied the message with Outlook. There are some changes to the text body. There was, for example, a little placeholder text there that reflected the alt text of that inline image. That's gone now after the IMAP copy, but no changes to the HTML body. There is a new thread index assigned, so that's repopulated essentially. There's a new MIME boundary, and again, it contains a timestamp there as file time. And this reflects the time that the copy operation was performed now. So we went from the send operation timestamp in the MIME boundary to the copy operation now. And this is again in local time. Now, here's another interesting thing. In some cases, you might see these nested MIME boundaries, which is pretty cool because it's kind of like an audit log in a way. So when you look at the HTML body and the HTML body's MIME boundary, now it has an additional inner boundary parameter, and that reflects the send time of the original email. And the outer boundary reflects the timing of when the IMAP folder copy operation was performed. So essentially, we have a fork now. The inner boundary shows us what the email's boundary used to be, and the outer one shows us what it became, and that reflects the copy of that additional operation. Some other observation here before we move on to the next operation. The message ID remained unchanged, which is good. So that is something we can usually rely on. And if you want to figure out what happened with an email, it's a good place to look because it's more permanent or static than the other data points, although it is possible to change that as well. The XMailer header stayed the same. There was an additional DKIM signature header there called X Google DKIM signature. That's DKIM signature that Google inserts there as a custom header. And it's notable that that didn't go away. So it could be that maybe Outlook is targeting the DKIM signature header by name specifically and taking that out. And because this one has a custom name and it doesn't match, it's staying there. But needless to say, because all those changes happen to the email, that DKIM signature no longer verifies because the email's body changed, headers have been reshuffled and their contents have changed. So there's no DKIM verification to be had anymore. And like I said earlier, HTML body hasn't changed. The content length has increased because of the additional MIME boundary, and a couple of the headers also changed position. Now let's get into editing the message. So previously we copied the message. Now we're going to rewind. So I'm going to go back to the original form of the message before I copied it. And I'm going to edit it now with the helpful feature from Outlook that allows you to go and edit the message in place. Again, we're using the same Outlook version for Microsoft 365, and the edit operation is performed a few minutes later at 11:36 p.m. UTC. Let's see what happens. Well, we can take a quick shortcut here because most of the artifacts related to the headers are exactly the same. So the headers haven't really changed for the most part. They're actually a hash match compared to the copy artifacts. So we can move past that. A couple of the headers that are dynamic values have been updated. One of them is the XOLKEID header, and the content type contains the MIME boundary, so that has been refreshed essentially. As far as the text body goes, again, the text body has the same change there, that placeholder text is gone. The line breaks here are a little bit different than what we observed in the copy artifacts, but largely similar. The big changes we see in this instance are the HTML body changes. When we edit the message, there's a lot going on with the HTML body of the message, and I'll highlight some of these. If you look at the highlights there, so we edited the message with Outlook 16, and we see immediately a new reference to a different Word version. It used to be Microsoft Word 14 before for Outlook 2010. Now we're seeing a reference to Microsoft Word 15, although we used Outlook 16. And there are references to a couple of additional files. One of them is named filelist.xml, and the other one is called editdata.mso. And there's another timestamp there, file time-based timestamp. So if we go through these, the file time-based timestamp equals to this, and that matches with the time that we saved the edited message. So not necessarily the time that we started the edit operation, but the time that we finished it. And there's some information about those referenced files in a Microsoft support article. It's not available right now, but it is available through the Internet Archive, so you can go read on that. There's noticeably significantly larger style section in the HTML body. And like I said earlier, now there are references to Microsoft Word 15 rather than 14, and there's a discrepancy there. When you edit a message with Outlook 16, it references Microsoft Word 15, at least for the time being. The final action that we're going to take on this message before we come to conclusions is to forward it. And I suspect that this is probably something you'll run into more often. because I see people forwarding emails all the time. For example, law firms forward emails. I get emails sometimes saying, hey, client forwarded me this email, so have it and take a look at it. Or even forensic examiners forward emails when they're passing things to each other or to counsel. So forwarded emails are quite common, and let's see what happens when somebody forwards an email with Outlook. We're using a similar workflow here, using Microsoft Outlook for Microsoft 365, and we're using the forward as attachment option there, so that messages forward as a separate attachment rather than in line. And we document the dates and times when we perform that operation. Now, right off the bat, we can see a couple of additional headers. There's a thread topic header, which is essentially the root of the email subject. So no big deal there. There are 3 exchange-related headers, Outlook/exchange-related headers. The XMS attached header that has to do with the fact that the email has an attachment. There's a header about the transport neutral encapsulation. So essentially, that's there if there's transport neutral encoding, encapsulation. That's a mechanism that Microsoft uses to encapsulate an email that contains complex data for transmission as a MIME document. In this case, that didn't happen, but if it had happened, that would be a message ID there. And then there's another record review confirmation type header there. So we have some additional headers, but we have quite a few removed headers, even more so than before. And again, a notable removed header there is the DKIM signature. So once again, we're losing that DKIM signature header just by way of forwarding the email. That is very notable here. We get a new thread index, again, similar to the copy and edit artifacts, and it is notable that it is the same exact thread index, so it's calculated the same way. A new MIME boundary, but wait a minute, this MIME boundary is a little bit different. So in the past, we had these MIME boundaries and they had those file time values in there. If you look at this MIME boundary, its structure is entirely different. And if you look at it next to the message ID, you can see how it's derived from it. So the message ID here is on the left side and the MIME boundary is on the right side. So you can see the different components of the message ID and how they came together to form the new MIME boundary. So that's quite interesting. And that is something that Outlook does when it's connected to a Microsoft 365 account and it's forwarding an email. It takes the existing message ID of the message and then uses that to form a new MIME boundary. We see that the origination date of the email is normalized. So it used to be that we had local time here in Pacific time offset. Now it became UTC all of a sudden. So there's some normalization there. The date value overall hasn't changed, but we see that the time offset has changed. We see that the participant headers have been normalized. So there's some additional codes there and participant names added to the email addresses. And some of the header field names have been lowercase for some reason. You see them highlighted there, so they will turn to lowercase. Now let's look at the attachment headers. So just to summarize what we're looking at here, remember I told you that the MIME message has different parts, and each MIME part is essentially a separate entity. And just as the main email has headers, each MIME part can have its own headers. In this case, this is an attachment part, and the attachment MIME part has headers. And these are the headers of that MIME part. And here's the before and after. So before the forward, it looked like that. There were 3 headers. And after the forward, there's an addition of a header, the content description header. And then the existing content disposition header has some new parameters now. One of them is size, which makes sense. So that is the size of that zip file. And then it has a creation date parameter added to it, and the modification date parameter added to it. But it is important to note that neither of these dates are really the dates of that zip file. They have nothing to do with it. So those are the dates of when the forward operation happened. And this is another gotcha. So you can look at an email that you received and perhaps it was forwarded. When you look at the headers of the attachment, you might see some future dates there that don't seem to belong with the email, but really they're not part of the email or part of the attachment. They are future dates because the message was forwarded in the future compared to the original sent time of the message. And it is also notable that these 2 timestamps, although they reflect roughly the same time, are 1 second apart. So it gives us a clue that perhaps Outlook is not creating one timestamp and reusing it, but maybe calculating those timestamps separately. When we look at the inline attachment, we see that similar situation here, some additional headers and some additional parameters. And again, we see some timestamps there. And again, same situation here. The timestamps reflect the time of forward and not necessarily the timing of that zip file. And notably, these timestamps are 1 second lagging compared to the timestamps we looked at before. Overall, as far as the body goes, there are a few changes. The encoding of the body has changed, and then there was a placeholder text that's a description now that has square brackets around it. So not a huge change there. And HTML body changes are also fairly manageable. There's some lowercasing happening and some additional quotes and stuff, but the HTML body remains mostly the same. And as far as other observations goes, again, similar situation. The ex-Google DKIM signature remains, but it doesn't verify. There's position changes. The ex-mailer header remains the same, and message ID header remains unchanged. So we summarized what kind of artifacts we saw in this case with Outlook, but really this applies to just about any email client. I chose Outlook here because it's commonly available and we encounter it all the time. But what are some of the takeaways from this? Well, number one, the point I wanted to make is that there's quite a bit of detail in email evidence beyond just the basic email metadata, and it is usually helpful to dig into that and analyze it if the investigation warrants it. You might be able to use such information to, for example, corroborate other evidence. Maybe you have witness testimony, or maybe you have logs, and what you see in those logs or testimony or other sources, does it match with what you see in the message or not? The second thing is, if an email message becomes email evidence, then an email client should no longer touch it, because if it touches it, these are the things that can happen. So no forwarding an email, no copying the email between folders, no dragging an email from your email client out to use it as evidence, as a lot of people do from Outlook, for example. So when I say that, I get some frantic responses sometimes, like, oh, then what are we to do? We have this evidence. How do we capture it? How do we turn this over to our expert? So you have some options there. If this email, for example, sits in a mailbox, then life is good. You can connect to that mailbox through an API or protocol in a read-only manner with a forensic tool, preferably. Capture the email without any changes, capture the surrounding server metadata, preserve it in a container, forensic container, produce it. Life is good. If the email is local, perhaps it's in an Outlook data file, like an OSD file or some loose messages here and there, then the regular forensic practices apply. You make a forensic image or perform a targeted collection, put it in a container. One important note there is that if it is in a larger container and it has to be isolated, then you don't want to do that isolation with an email client. For example, in an OSD, you don't want to go in there with Outlook and find that message and drag it out, because that'll change things. You want to ingest it into a forensic tool and let the tool do that in a forensically manner and isolate that message. Finally, how do we kind of apply these at large? Like, how can we apply this to a larger scale investigation? And there are a couple of things that I like to do there. One of them is contextual analysis. So some of these data points we looked at, for example, to thread index or the message ID, they're designed to be unique by nature. So if you're receiving a lot of emails and investigation of, let's say, fraud or bad actors or things like that are on the table, and one of the things that you can do is you can classify those emails and group them by those supposedly unique identifiers and see if there are any non-duplicate emails that share the same values. If they do, then they can go into a separate bucket for further analysis. Another thing that I like to do is timelining. Probably all of you or a lot of you do timeline analysis, right? And you see all these timing information you can capture from an email, and why not include that in your timelines? For mapping messages, life is good, because if you're working with an MSG file or an OSD or an Outlook or an Exchange data store, all those emails have mapping properties and they're clearly defined. They have specifications and they have data types. So you could easily sweep through all datetime type mapping properties and put them all in your timeline, even if you don't know what those mapping properties are. If some of them hits in your investigation, then you can go back and figure out what they are and solve the problem. Whereas, there will be some mapping properties there that are not datetime types, but they do contain timing information like the conversation index, and they will require some special handling. And then for MIME type messages, you would want to include these timestamps for MIME boundaries and message IDs and anywhere else that you can get and put in your timeline. And then once you look at the structure of the data and patterns, then you'll be able to see, oh, maybe these messages have been moved together, or maybe they've been exported at the same time, or perhaps they were forwarded all all in the same email. So you'll be able to get some critical information from there sometimes. Well, timing is spot on, I think. So I'll turn this into you. If you can find my socials there. If you have any questions, I'm all ears. Thank you.